Oh, hello and welcome back, everyone. Today we are finally back again with a whole different video from the usual tutorial that you're used to see. The reason being, honestly, I don't want to recreate this entire thing by hand. It's also a particularly simple network and we have to look at a whole lot of things, so I decided I'm just gonna show you each and every single node with their non-default parameters only if I have done something that is worth noticing. That way we can kind of speed run through the entire thing. Now, if you've looked at the title of this video, you might have seen this little thingy called the golden angle, which is the basis and like the initial premise behind this entire thing. And before we can express or trying to even comprehend what a golden angle is, we need to understand what a golden ratio is and what a ratio is in itself. But where did this whole thing started? Well, it started with me finding this random Instagram reel, like showcasing itself on my Explore page or something like that. I don't honestly remember. But what it is being explained in this video is that if we spawn a new point, a new instance, a new leaf, whatever it might be, onto this specific angle called the golden angle, in essence, if we were to draw a line that goes from the very center to each and every single one of these dots, the lines would never ever end up overlapping onto one another. And this is very important because, for example, in nature you can have a scenario similar to this one, where if you spawn a new leaf at each and every single one, every single one of these leaves were to be spawned at that exact angle, what you end up with is that the leaves never fully overlap one another, and so you're essentially maximizing the amount of sun rays that is being caught by the leaves themselves. But in order to obtain this golden angle, we need to, as I've mentioned before, understand what the golden ratio is, and before that, even what a ratio in itself is. Now, I am no mathematician. I will put that already forward in front of me, but I'll try to explain it in the simplest of terms. So, most of you might be familiar with something called an aspect ratio, especially if you worked with TouchDesigner or multimedia applications for quite a while. But in case you don't, I've prepped this little example over here. So in this case, we have different noise tops, but each and every single one of these has a different set of horizontal and vertical resolutions. So we have some very common ones like the 1080 by 1080 or the 1920 by 1080, which you might simply know as Full HD. We also have 1920 by 1200, which is Full HD but 16 by 10, which is very much used by projectors or some older laptops. But what is even that 16 by 10 I just mentioned? Well, we can go onto any one of these top nodes and middle mouse button on them, we'll see something. It says the size of the texture is 1080 by 1080 and its aspect is 1:1. What this is expressing is that for each and every single vertical pixel, we have one horizontal pixel. So when these two numbers are the same, it just means that they have the same horizontal and vertical components. But if we have something, for example, like this noise, where I've simply multiplied it by 2, we can see that the aspect ratio in this case is, in a texture of 2160 by 1080, is 2/1. We also have, for example, in this case, 1920 by 1080, which is the most common resolution on the planet, which produces an aspect ratio that can be expressed into two different ways. The first one is by only using integer numbers, which results in 16:9, which is a number you may have heard a whole lot of times, or 1.77 over 1, which is usually just read as 1.77 because 1 is the constant in this case. This 1.77 is actually like what our main focus is going to be at, but just to show you some other cases of different ratios, we also have in the case of 1920 by 1200, we have 1.6, or in its integer part 8/5. Now this is an extra layer of precision that is not exactly needed, because this, if this was to be twice the values, we would actually have 16/10, which makes a lot more sense to a lot of you out there. I know it does. And we also have in this case a vertical resolution of simply taking a full HD and flip it vertically, also known as 1080/1920, which produces 0.5625 of an aspect ratio. Now, I know what some of you may be asking, why do we have two values over here that are expressing the exact same thing? It's because I went over and did something a little extra over here, where I took the texture and then I used a top method to get the width, and then I did the same to get the height, and then divided the width over the height. And then I did the exact same thing over here to show you that you can actually just ask any texture for its aspect method, and that will simply give you the aspect ratio. Now, if any of these numbers, instead of being what we've seen so far, happen to be this exact number over here, 1.618 yada yada yada, we have what it's called a golden ratio. Now, why is it important, a golden ratio? I'm going to leave you some extra resources down below, but in essence, it creates a very specific property. So basically, what's happening is that if we divide the bigger of the two components by the shorter one, and we get the longer ratio, it would be the exact same thing if we were to sum these two numbers and then divide it by the bigger one of these two, which creates a whole lot of properties and thingies and whatnot that we could potentially examine into another video, but it creates this looping sequence that is seen all over in nature, architecture, and art, as you can see from this image over here. So how do we get these two values? How do we get the golden angle, or how do we get the golden ratio? Well, it's actually surprisingly easy. When I started looking into this, I couldn't even believe my eyes. But in order to get the golden ratio, all you gotta do is write this expression, which is 1 plus the square root of 5, and then grab this entire thing and divide it by 2. That's it. Nothing more, nothing less. Then, if we grab this value and plug it into this other expression, we get the golden angle. That expression being 360 divided the golden ratio, but squared. This is squared for those of you that don't know it. And as I showed you at the very beginning, if we keep on adding points to this copy pop, it doesn't really matter how many we do. If we were to draw lines from the very center up to each and every single one of these, they will never, ever, ever overlap. By the way, what is even happening inside of this copy pop? I'm glad you asked. Well, we have a point at the very center, and then we're adding copies in a very simple way. We're telling each new copy that it needs to be at 0.15 units from the previous one, and then it needs to be rotated by our golden angle value. And that's it. There's nothing more to it. I've also done a little bit of an extra layer in here where I normalized the overall scale of what these, I'm used to call them instances, but they're actually copies. But essentially, no matter how many copies I decide to add over here, they always stay within that maximum radius of 0.5 or maximum diameter of 1. Now, I know what some of you may be asking, especially those of you who have seen an older video of mine. Ruben, why the hell aren't you using the aligned scale? Well, that's because I've come to discover that apparently it's slightly bugged, at least in this version of TouchDesigner. I haven't updated in a while. So I ended up using a little bit of an older structure and an older formula, which is normalizing this entire thing. I'll leave this in the description and maybe I'll explain it a little bit further down there. But yeah, this is just making sure that this never goes over this diameter of 1. That's all you really got to know about it. Now, as to what is going on with the rest of the patch is actually surprisingly simple. This copy pop that we had over here, we have added a new value over to the rotation Z of this other copy pop over here. And this value is being generated by the ARV component by Sarv. So we have an audio track that you've listened at the very beginning of this video. We're only extracting the kicks of the track, and let me reset it so that way we will see it happening whilst we talk about it. So the little quote-unquote issue with this value, it's that it's a Boolean value, meaning that it can only be 0 and 1, and we needed something a little bit different from that. So I went and rearranged the value, so it's no longer 0 and 1, but it's instead 0.05 and 0.5 in the to range section of our rearrange. The 0.05 is actually very easy to explain, and it has to do with the way that the speed chop works. So if this happened to be 0, every time that a kick isn't coming through, this entire thing would simply stop. And I can show that to you, I guess. It just comes to a stall, and I didn't really like that, so I wanted a bare minimum movement of 0.05. And then the 0.5 is simply because with 1, it was just a little bit too much for my taste, but of course you can do whatever you want. And then we also added a lag. So when lagging up, we have a much lower value, and when lagging down, we have a much higher value, meaning that going up, it's almost instantaneous, but going down is a little bit slower. And then the speed is just unaffected, and then there's a null chop. There is also this count over here, which we're gonna talk to. We're gonna talk about better later on, but it's only looping through 0 and 1. So loop min max 0 1, nothing more, nothing less. It will make a little bit more sense, but you might have already understood where this is being used inside the network. Other than that, we are also doing the same trick that I pulled for this other instances down here. Sorry, they're not instances, they're copies. Where it's just kind of bound to this diameter, but I'm redoing it in 3D space instead of just a 2D flat shape, but it's the exact same thing. I'm not pulling anything else other than this. Then we have 2 paths that we can follow. So we'll start with the bottom one because it's a lot easier to explain. And also, I'm gonna wait until, actually, you know what? I'm gonna rearrange something real quick. Here we go. So these lines that you're now seeing over here, they're being generated by a proximity pop whose only value of change is the maximum distance. I believe this is 0.1 in its default state. Yeah, exactly. I've just made it a little bit larger, and that's it. Nothing more, nothing less. Send it to a geometry, and then assign it a Phong material, GPU tessellation, and a line width of 4. I can now plug back in the pixel stretch top, which we're gonna talk in a second. And then on the upper side, we have the spheres comp by 𝚑𝚑𝚝𝚑. If you worked with point clouds, you already know this is literally the best component that has ever come around for any kind of point clouds work, but what this does, well, it's actually a little bit more complicated that I really wish to speak about, but it's rendering all of these fake spheres onto little quads that are always pointed towards the camera or the local viewer. But yeah, there's we can make an entire video about this component, so I'm not gonna speak too much about it, but this is doing instancing, but far better than your normal setup. It's a lot lighter to run as well. So if you don't know much about this, yet again, I'm gonna leave a description, a link in the description, which further explains why this is such a huge deal. And yeah, let's just go over to the rest of the scene. So what do we have here? Right now, I've decided to render this as a cube map and then pass it through my own Panini talks or Panini projection talks. It's somewhat similar as if you were to just go down here and render in your standard 2D render mode, but I wanted to add it because I'm thinking of making some extra changes. But for you, it shouldn't really change too much. It's still like a scene which is being seen by a camera, and there's also a light in the scene to add that little more detail. Now you might be asking, what the hell even is this component over here? This is not just a standard camera, and you would be right. Let me show you by going to our geometry viewer. So we have our camera over here. First of all, I have done the pivoted camera trick. For those of you that don't know it, if you change the transformation order from the default scale, rotate, translate to scale, translate, rotate, this number actually, the translation Z expresses how far away you are from the center of the scene, and then the rotate is simply the degrees that you revolve around the geometry. That's it. And it's a very, very cool way of doing things in TouchDesigner that a lot of people ignore. And then this set of custom parameters has to do with the fact that I've customized this camera to do some extra little thingies. Let me show you. Let's see if I can catch the correct one. It should be project 1 cutoff camera. Oh boy, I think it's this. Should be. And I'm going to now enable slicing. And what this is doing is it's altering the values of the near plane and the far plane so that it's only cutting off a very specific slice. We can increase how deep that slice is or how thin it is by going a little bit down. And we can also select whether to use auto distance, which in this case is simply the distance from the camera to the center of the 3D world. It can be the distance between the camera and a custom reference object, or it can be simply a custom distance that we can scroll through, such as this. So as you can see, we're scrolling through the entire sphere. But yeah, we don't really care too much about this component. I'm gonna leave it in its default state after the slicing though, because I still think it looks kind of cool. And whoops. Yep, there we go. Let's actually go back to our top viewer, because some of you might be particularly interested in what the hell even is happening outside, or rather like after the Panini projection. So over here we have two nodes which are made by one of the greatest TouchDesigner artists I've ever had the chance to know, which is 𝚑𝚑𝚝𝚑. Insane recommendation for all of you. These are custom plugins that he's built. I'm gonna leave a link to the description, and what they're doing is simply either creating a pixel stretch effect, which was very popularized by Photoshop online community, and after that some other like editing kind of communities, as well as a pixel sort top that he's built, and they're freely available for anyone to grab. yet again, I'm gonna leave a link in the description. And after that, we don't really do much more. We're adding a white background with nothing else to it. Then I'm using the color lover picker, probably the most overused component in the entirety of TouchDesigner history. A lookup to assign the color from the color palette that we decide to use. Here I'm also using a little bit of extra composite options. In this case, I specifically went for the multiply, which we can send over here to get a slightly different look, or a series of different looks by just choosing a different palette. But yeah, other than that, there isn't anything more to this patch. I told you it was surprisingly easy, and there isn't many values that I really needed to show. I think it came out pretty darn cool. And yeah, thanks for watching. You'll find yet again in the description every single possible link that you may need for custom components, custom plugins, whatever else I ended up speaking about. And thanks again for watching. I'll see you very soon. Bye bye.